Problem 3. This is on the game Angry Birds, quite popular game with the younger and the older generation. So what we are given is the height at which the pig is located, the velocity of the angry bird, and the theta angle which the direction of motion makes with the ground. What we have to find is d, what distance should be there between the catapult and the structure which is holding the pig. Now in this kind of motion, which is examples of motion, which is a projectile motion, we separate the horizontal and the vertical part of the motion. So first of all, using standard trigonometry, the initial velocity in the x direction will be v cos theta, v naught cos theta, and v naught sin theta would be the one in the y direction. Now both horizontal motion and the vertical motion will be decoupled, disjoint, completely independent of each other, and they are linked together only by the common time interval t. That is, both the horizontal and vertical motion will take place for the time capital T when the angry bird hits the pig. Now for horizontal motion, it is uniform motion, there is no acceleration, so v naught cos theta will be the speed with which the angry bird will cover the distance d in time t. Therefore d v naught cos theta times t. So this is one result which we get, called equation 1. Now let's see in the vertical direction. The vertical direction, we are assuming that the catapult is pulled back enough so that the motion starts from ground. The angry bird starts from ground with the initial velocity of v naught sine theta. It goes until the maximum point, so this is O, it goes until A, and then where the velocity becomes 0, and then it turns down, does a free fall until it hits the pig P located at height h. Call the maximum height which the angry bird reaches as HA. Now the total time of flight t is composed of two parts. Basically, the total motion is composed of two legs. One is the motion from O to A and another is from A to P. So total time will be the time it takes to go from O to A and the time it takes to go from A to P. Now we'll separately consider these two legs. So let's consider the leg when the angry bird goes from O to A. So now we use the standard equation in kinematics, x t o a. Before that we can use the equation for velocity, that is v at time t o a equal to v at time 0 plus acceleration t o a. Now v at t o a basically means v at the time when the angry bird reaches A. This is 0. v0 is v naught sine theta. Acceleration is minus g. This is t o a. So t o a is v naught sine theta by g. I can call this as another equation 2. Now we can use the standard equation of displacement, which is x t o a is equal to x naught plus v 0 t o a plus half a t o a square, and you just substitute the value of t o a in this equation. x0 is 0, v0 is v naught sine theta, and xtoa is nothing but equal to ha. Xtoa is the distance which the angry bird will travel from 0 to A. So after substituting, we can easily get ha to be equal to v naught square sine square theta by 2g. Now let's consider the motion from A to P. So in this part, to consider this motion, the motion taken from the highest point till P, the distance is HA minus H, and we can consider the motion to start here at time t equal to 0, and the initial velocity is 0, and the initial x is also 0, and it continues until time t equal to TAP. So we can use x TAP is equal to x0 plus v0 TAP plus half a TAP whole square. X TAP is HA minus H. This is all 0. Half acceleration is g because it is accelerating in this direction, g TAP square. So now we get TAP is equal to 2 HA minus H by g square root, which can be further simplified as 2 by g, and we substitute the value of HA from here, v0 square sine square theta by 2g minus h, and call this equation the third. Call this equation, because this also will be handy, as the fourth equation. So now we write down all these four equations to compute the quantity of interest. So we have the equation 1, equation 2, equation 3 can be further simplified by taking 2 by g within the square root, and this is equation 4. Hence now let's first compute total t. That will be computed using these two equations by substituting the value of TOA and TOP from 2 and 3 and 4, and that will be equal to v0 sine theta by g plus v0 square sine square theta by g square minus 2h over g. Therefore, now from 1 we have the answer, which is what we wanted to find. D, let's make it a little big because it's the answer, and let's change the color. D is equal to v0 cos theta times t, which we just evaluated here, v0 sine theta by g plus under root of v0 square sine square theta by g square minus 2h over g. That's the answer. That's the final answer. Note that this answer really makes sense if the quantity here is greater than 0, which implies h should be less than equal to v0 square sine square theta by 2g, because otherwise this will be root of a negative number, and that is an unreal value. And this is also intuitively makes sense because v0 sine square theta by 2g is the value of HA, so that's the maximum height Angry Bird can reach. So this is HA. So only until HA, which is this value is equal to HA, is bigger or equal to h, which is the height of the pig, this makes sense. If the pig is located at a height larger than HA, the Angry Bird will not be able to hit the pig. So that was just a small side note.